You have a test coming up, right?
Yeah, I have one tomorrow.
Okay. So, hold on one second. I gotta be able to write on my screen. Okay. Shoot. Tell me a problem that you want to work on.
So it's solve each equation by graphing, and the first one is x squared minus 5x plus 4 equals 0.
All right. Can't really solve this by graphing, but we can solve it by factoring.
Oh.
Okay. Can't solve it by graphing because I don't know how to graph that. Nobody does. But we can certainly solve it by factoring. Factoring is a necessary skill that you have got to learn to get through Algebra 2. Okay. I don't know how they've taught you to factor. There's various methods of teaching people how to factor quadratics. I have quite a simple method, especially for first order quadratics. And I call this a first order quadratic because the x squared term has a coefficient of 1. Okay.
2.
So do you know how to factor this? Work it through me step by step.
So separate the two x's.
Okay. To what? Separate them how?
Like put an x in the first parenthesis and the x in the other.
Good. That's first step. Second step, determine both signs. Because that is plus 4, what do both signs have to be? Remember, if factoring is just the reverse of FOILing.
So they're both opposite.
No,
right?
they're both the same. Only the same signs would produce a plus 4. Very, very important that you understand that. You cannot produce a plus 4 unless both signs are the same. Now the question is, are they both minus or are they both plus?
Both negative.
Because of the sign of the middle term.
Yeah.
As long as that's negative, that means they're both negative. Now, what's the rule? The third step is quite easy. Verbalize it for me.
Find the greatest common factor.
No, looking for factors of the number 4 that do what?
That add up to it.
5. Not minus 5, but 5. So let's examine factors of 4. We got that, we got that, we got 2 and 2. That's it. Which factors add up to 5?
Wait, sorry, I'm trying to fix my screen right now.
That's all right. In other words, whenever you don't know how to do that third step, go ahead and write out all of the factors of that constant.
1 and 4.
Correct. And since they're both minus, it doesn't matter where I put the 1 or where I put the 4. I can put them, I can switch them if I want. So that is that quadratic factor. Now what is the solution? There's 2 of them. There's one fundamental principle of algebra, Maddie, that you have to memorize. And that is, when you have 2 things multiplied together that equal 0, one of them has to be 0. You cannot multiply 2 numbers together and get 0. Impossible. So if you have A times B equals 0, either A or B has to be 0. So the way you take the next step in solving this is by setting each one to 0. And if you do that, what do you get for solutions for x? If x minus 1 has to be 0, what is x?
0.
No. Here's the equation. X minus 1 equals 0. I know that is true. So what is x?
1.
Now x minus 4 is 0. What is x?
4.
There's your two answers right there. Now, if they're talking about graphing it, well, I know I'm looking at a parabola, right?
Mm-hmm.
All quadratics are parabolas. And I know it opens up. And I know what my two zeros are. There's a 0 at 1 and there's a 0 at 4, so that quadratic must look like that.
How do you know it looks like me?
Goes through those two zeros of 1 and 4. Now, I wouldn't know that when I first look at it unless they want you to graph this on a calculator, a graphing calculator, and then read the zeros from whatever your calculator says. It's possible that that's what they wanted you to do. But even if that's what they wanted you to do, you need to be able to do that step right there. You need to be able to solve for the zeros.
So like right next to it, there's like a table box of like X and Y next to like the graph.
Yeah, you don't even need that. Trust me. Okay. Here, let me close this out and restart.
I just feel my math teacher would mark me wrong, like if I don't have it, because.
Well, might be better if you sent me a picture of your review material so I could know exactly what he's looking for. But
okay.
The problem you gave me, it's really clear to me everything you need to know about that problem.
Okay.
Okay? What else you got?
Can we do another one of the same?
Sure.
Kind of thing?
Sure.
4x squared plus 4x plus 1 equals 0.
Like that?
Yes.
Okay. Again, I can do this two ways. I can put this function into my graphing calculator, and whatever it shows me, it's going to show me something like this, and I'll figure out what those two solutions are. So I can do it graphically, but you need to be able to do it algebraically also.
Okay.
Okay? So let's erase that. In other words, we're assuming we don't have a graphing calculator. One. Because in a way, a graphing calculator is cheating a little bit. In other words, there's nothing wrong with asking you to do that, but you need to be able to solve this algebraically. That's all there is to it. That's definitely a skill in algebra that you need to know. Was it equal to 0 like that?
Yeah.
Okay. So the first step in factoring this would be to see if you can find a greatest common factor. Is there one? That's always the first step, incidentally. Even if you can factor it, you are always looking to simplify it by finding a greatest common factor. There is not one. There is nothing that divides into all three of these terms equally. So, assuming there's no greatest common factor, and assuming that we're not looking at a difference of perfect squares, folks, there's only one method left. And that's this method. Now, what we're looking at here is a second degree of quadratic. This is not the simplest kind. The simplest kind is always a 1 in front of the x squared. So if we do not have a 1 in front of the x squared, like in this case we have a 4, then it's tougher to factor. And it becomes kind of a trial and error process. So the first step is still the same. You have to break up the 4x squared. It's the most likely way we're going to try to break that up.
By separating the x's.
Tell me what it's going to be. Exactly.
So 2x in each of the squares, like.
Yeah, that's a good starting spot. That multiplies to 4x squared, as it has to. What are both signs? Always the second step, always. Figure out both signs. Not one sign, both signs. In other words, a really important concept in factoring is you never figure out the first factor and then the second factor. You always kind of figure them out together. What do both signs have to be?
They both have to be negative to make the positive at the end.
Well, two negatives would make a positive for sure, but that means they both have to be positive. In other words, when this is a plus, you know they have to be the same. They either have to both be negative or they have to both be positive. And the way you decide is by looking at the sign of the middle term. Well, in this case, the sign of the middle term is positive. So they both have to be plus.
Okay.
What are factors of 1?
1.
That's it. 1 and 1. That's our only choices. Now, the question is does that give you the middle term? In other words, it's only correct if the middle term ends up being 4x. Well, how do you decide?
So do you like set it to 0?
No, just hold on a minute. We're trying to figure out whether these two factors multiplied together equal what we started with. Remember what factoring is. It's just the reverse of foiling. That's it. The middle term, when you FOIL, is always the sum of the inside and the outside. What I call my double smiley face. And that's an important concept. Whenever you're factoring, you need this double smiley face to figure out whether you have the correct middle term. Well, what's the inside multiply to be?
3. 3x.
What's 1 times 2x?
Oh, 2x, sorry.
Okay.
I was adding
What's
them.
the outside turn out to be?
Also 2x.
Add them together.
4x.
You got the middle term with the right sign. And what that tells us is that we did it correctly. Okay? That's all it tells us. But that's what you need to know. When you're factoring, you need to know, did you do it correctly? If this did not come out to be 4x, we didn't do it correctly. And we got to try other combinations. That's what factoring is a trial and error type process. Especially with these second degree quadratics. Okay? So, now we have 2x plus 1 times 2x plus 1 equals 0. Where do we go from here?
I don't know how to like say it, but like.
Well, it's the most important concept in algebra.
Yeah, you like
I'm not exaggerating that. It is the fundamental rule of algebra. Let me state it for you. If you have two things multiplied together that equal 0, one of them has to be 0. Remember that. Okay? So given that, one of these two things has to be 0. So I'm going to set 2x plus 1 equals 0. Solve that for x.
It's just still 2x.
Solve this equation for x. They want what x is in this equation. So you have to solve this for x. How do you solve that equation? All right, let's talk about solving equation. Okay? When you are solving, what I have an arrow pointed to right there, when you are solving that equation, you want to get rid of everything but x. You want the last line to be this. So what's the first thing I got to get rid of?
1.
Okay, how do I get rid of it?
You subtract both sides.
Okay, so that leaves me with this, correct?
Yeah.
What's the next thing I got to get rid of?
2x.
No, just the 2.
Yeah.
Well, what is the 2 currently doing? Is it multiplying, adding, subtracting, dividing?
Multiplying.
So you do the opposite. What's the opposite of multiplication?
Dividing.
Okay, so I'm going to divide both sides by 2. Remember with algebra, you can do anything you want on one side of the equation as long as you do it to both. And by dividing both sides by 2, those 2's cancel, and I end up with my x. What's x equal to?
-2.
Negative 1/2.
Oh, it just stays the way it is.
Yeah, look at my screen. There's the negative 1/2 right there. Now, normally the next step would be to set that equal to 0 and solve it. But it's the same thing, so I know I'm not getting a different solution. I'm getting x equal negative 1/2. That is the solution to our parabola. Now, let me go just a little bit further. In other words, a graphical representation is extremely important to understanding math. So if I were to try to figure out what this graphs as, it's clearly a parabola, right? All quadratics are parabolas, every one of them. So they're either pointing up or pointing down. The question is where does it cross the x-axis? Well, where does it cross the x-axis? That's what that means. That's the x-intercept.
Yeah.
So it crosses it at -1/2. And it doesn't actually cross it. Since we only have one solution, it has to be that. It has to be a parabola that touches the x-axis just once. In other words, if we had two different solutions, that parabola would go through the x-axis and I would have two x values. Since I only have one solution, x equal -1/2, that tells me that that parabola is going to kiss the x-axis only at x equal -1/2.
So how do you tell whether it's facing up or down?
The sign on the coefficient of the x squared. If it is positive, it's up. If it's negative, it's down.
Oh, okay.
Simple as that. Apologize for this scribbling that appears. I haven't quite figured out what to do about that. But all right, what else you got?
Let's do one more of those.
Okay.
So 2x squared minus 12x equals negative 17.
When you are looking at a quadratic that has an x squared, has an x, and has a number, always you want to put everything on one side and leave 0 on the other side. So that's what we're looking at here. We see an x squared term, we see an x term, and we see a number. So what's my first step?
Sorry. So put your have your two parentheses, separate the x.
Not yet.
No.
Not yet. We got to get everything on one side. That's the first step. And 0 on the other.
Oh, okay, so.
Okay, so the first step is to do this. 2x squared minus 12x plus 17 equals 0. Now we have it in the form of a normal quadratic. And now we're going to put our two parentheses. First step.
Separate the x's.
Do it.
So it would just be x in both of them.
Now hold on. If I put x in both of them, remember that this term comes strictly from these two things multiplied together. Nothing else. Well, x times x is not 2x squared. So that's not right. So what do I have to do? What's one of the terms have to be?
X.
About x and 2x.
Sure.
Or 2x and x. Doesn't matter. Now, when I multiply 2x times x, I get 2x squared. That always has to be true. In other words, this thing that I've circled only comes from these first two things multiplied together. The f of FOIL. Just like the number only comes from the L of FOIL, the last two multiplied together. But we're not quite there yet. The second step is still to do what?
Figure out the signs.
Okay, what are they?
So they're both different. Like.
Nope. If they were both different, that would be a negative 17.
Oh, yeah.
That 17 comes from the last two numbers being multiplied together.
Both negative. So
they're both negative. They have to be. First of all, we know they're both the same. Second of all, we know they're both negative because the negative in front of the minus 12x. If that was a positive 12x, they'd both be plus. Okay, what are factors of 17? It's only one. One set of factors. 17 is a prime number.
It's only one, right?
1 and 17, exactly. 1 and 17. That's the only factors of 17. So I'm going to try 1 there, 17 there. Does that produce the proper middle term? Remember, it's the double smiley face that produces the middle term, always. If I draw a smiley face, that's the inside, that's the outside. Add them together after you multiply them together, and you get minus 12x.
No.
Okay, that doesn't work. Let's try 17 there and 1 there. That's the only other possibility. Does that work?
No.
No, it does not. So what does that tell us? In other words, that tells us that we can't factor it. It's not factorable. Well, if it's not factorable, what do you do? There's only one place to turn when it's not factorable. It's called what? Quadratic
Formula?
Yeah. What is it?
I don't know.
Got to memorize it, Maddie. You cannot get away without memorizing it. Seriously, when you take your SAT test or your ACT test, they're going to ask you what the quadratic formula is. A lot of places teach it to you in the form of a song, much like I got my ABCs taught to me. To this day, I could not tell you whether J comes before I without singing the song. Seriously. I have to go A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. K comes after I. Okay?
Yeah.
Quadratic formula is quite similar. It's pretty complicated. You got to memorize it. I don't care how you do it. Figure out some way to do it. A lot of schools teach it to you in the form of a song. You know that song? I don't know it, to be honest with you.
No, I don't know it.
Okay, well, I'm going to give it to you, but that's not going to help you. You got to memorize it. Whatever method you want to use, that's what it is. X equals, and what they mean by that is the solution to this quadratic is X, and it's going to equal minus B plus or minus the square root of B squared minus 4AC, all divided by 2A. Quite complicated, but what can I say? Math doesn't leave you any options here. They say memorize it or fail. Pretty much it. I can't do a mind meld with you to get you to memorize it, so you got to figure out how to memorize it. Now, let's talk about what A, B, and C is. What's A?
2x. So,
Just the coefficient. Ignore the variable. A is 2.
oh,
What is B?
12.
It's minus 12.
Oh.
Very important. You have to take the sign also. What's C?
Negative 17.
What's the sign in front of the 17?
17. It's just positive.
Then it's positive 17. Okay? With me?
Yeah.
Let me make some room here to keep writing upstairs. One of the problems I have here is that I always run out of room. I like to write big so people can see what we're talking about. Unfortunately, I run out of paper. Okay, so I'm going to take this A, B, and C and plug it into the quadratic formula. So I got X equals what? What's negative B?
Positive 12.
Good. What's B squared?
24.
144.
Oh.
B squared is minus 12 times minus 12.
Yeah, sorry. So I just
44. And then the way I suggest doing this last part is to not do any math in your head, to substitute the A and the C. What is A?
2.
What's the C?
17.
All of that's divided by 2a. 2 times 2. With me?
Yeah.
Now you have to simplify it. And again, let me erase some of this stuff. In other words, we've got our answer right there in blue, but it's not simplified. We want to simplify it. So the first step in simplifying it is to figure out what this 4 times 2 times 17 is. What is 4 times 2 times 17? You have a calculator?
Yeah, that's what I'm doing right now.
Okay.
$136.
Okay. What's 144 minus 136?
$8.
See how I got to that line?
Yeah.
Okay. Now, we can actually simplify root 8. What is root 8? And you need to simplify it. In other words, the purpose of simplifying radicals is to try to bring a whole number outside the radical. How can you factor 8? Can you factor it into two numbers where one of them is a perfect square?
Can you simplify it to 2 squared?
2 root 2.
Yeah.
That's what it is. All right, so I'm going to do that. Instead of root 8, I'm going to call it 2 root 2. Same thing. Now notice there's something I can do to simplify the whole answer. What is it? I'm looking at nothing but even numbers. What can I divide top and bottom by?
2.
Okay, what do I get? If you divide top and bottom by 2.
6 plus or minus 2 and 2 squared.
Root 2. 2 goes away. If I'm dividing by 2, that becomes a 1.
Oh, yeah. Divided by 2.
Okay, that's your answer. Cannot be simplified further. It's actually 2 different answers. Here's one of them. 6 plus root 2 divided by 2, and 6 minus root 2 divided by 2. Those are your 2 solutions. In other words, that's where it crosses the x-axis. If I'm plotting this as a parabola, I know that one of the solutions is about 3 and change, and the other solution is 6 minus root 2, that's 4.6 divided by 3, that's about 2 and change. So those are my 2 zeros. You with me?
I don't know where you got the 2 and 3 from.
Well, I took 6 plus root 2 divided by 2.
Oh.
Root 2 is like 1.4.
Oh, okay.
So that'd be 6 plus 1.4, 7.4 divided by 2 is going to be 3 and change. And then the other solution is 6 minus 1.4 divided by 2. That's 2 and change. I don't put the exact decimal here because we don't ever do that. At this level of algebra, we leave it in the radical format. But if I wanted to graph it, it's useful to know where those zeros approximately are. I know the original quadratic points up, so I know how to graph it now. Got a graph like that. That's the only way you can have a parabola go through those 2 zeros and point up. is it looks like that. And that's your whole answer. And if somebody asks you, what are the two zeros? What are they?
2 and 3?
No. What are they exactly?
I
don't want any approximations. At this level of algebra, you do not give approximation. You do not round off a radical to a decimal. So the two zeros are down here. There's one of them. 6 plus root 2 divided by 2. That's one of them. And the other zero is 6 minus root 2 divided by 2. Those are your exact zeros. And any test that you take is going to require these answers down here, not 2 plus or 3 plus. Only reason I put that up there is to give an approximation as to how this graph would look. But that's all it is an approximation. If we want the exact answer, we need to leave it in radical form. Remember, when you have radical 2, that is not a rational number. It's irrational, meaning it's a decimal that goes on forever, which means there's no way we can write it accurately as a decimal. The only way we can write it is as a decimal rounded off. That's not accurate. What's accurate is root 2.
So how do I graph it?
Just like I've done right here.
So if you go
that
2
zero is 6 minus root 2 divided by 2. That zero is 6 plus root 2 divided by 2. That's how you graph it. You graph your zeros. Now, in order to actually graph it, you kind of have to do a decimal approximation. But if somebody is saying, where are the zeros? They are at 6 minus root 2 over 2 and 6 plus root 2 over 2. That is a precise answer. Is there anything you don't understand about this?
It's just graphing really weird on my paper.
Well, anytime they give you something and they ask you to graph it, let's say I give you this. And I say graph that. Well, if I know it's a parabola, right? Does it open up or down?
Down.
Nope. What's the coefficient of the x squared? Is it positive or negative?
Oh, okay. Yeah.
That's the only thing you care about.
I thought it was the middle term.
Nope. It's the first term. In terms of whether the parabola goes up or down.
Okay.
So we know the parabola goes up. Okay, like that. Well, the next thing to determine is where it crosses the x-axis. Well, that's the zeros. If I let that thing be equal to 0 and I factor it, I get x minus 5 times x minus 2, which makes my zeros at 2 and 5. Well, there's only one way that can graph. It's got to go like that. Now, there is another very important point, which is the vertex. But so far, you haven't asked me where the vertex is. That's a whole nother issue.
Yeah, because I was just about to ask that.
Okay, I can give you formulas for figuring out where the vertex is. Because to accurately graph this, you need 3 points. And usually the 3 points you need are the vertex and the 2 zeros. When I say zeros, that means where it crosses the x-axis. And you get those by factoring. Now, there are a bunch of ways to figure out the vertex. First of all, parabolas are symmetric. So there must be a vertical line that is halfway between those two vertexes. What's halfway between 2 and 5?
2.5.
Well, is it? In order to determine whether something is halfway, figure out what the first half distance is. Is that the same as the second half distance? Actually, the way to do it is just to add the two numbers together and divide by 2. That's the simple way to do it. So where is the line of symmetry? That's what that dotted line is called, the line of symmetry, the axis of symmetry. Because that parabola is symmetric on either side of that dotted line. So where does that dotted line go through? Add the two zeros together, divide by 2. What do you get when you add the two zeros together? The two zeros are at 2 and 5. Add them together.
7.
Divide by 2. 3.5. 7 divided by 2 is 3.5. Now, just verify in your own mind that that's halfway between 2 and 5. How far is it away from 2?
3.5.
No, it's 1.5 away from 2. It's 3.5 minus 2. How far is it away from 5? Subtract it. 5 minus 3.5. That's how far away it is from 5. It's 1.5 away from each point. You see that?
Yeah.
That makes it a midpoint. That's the halfway mark between 2 and 5. It's 3.5. And I got it by adding 2 plus 5 and dividing by 2. And it doesn't matter, one could be negative, one could be positive. That's always the way you get the halfway point. You add the two numbers together and you divide by 2. What that tells me is that the coordinates of that vertex, the x-coordinate is 2.5 for sure, or 3.5, excuse me. And then to find out the y-coordinate, you just plug the 2.5 into your original equation, and you figure out what the y-coordinate is. And then you have your 3 points. You have your two zeros, and you have your vertex. If you can figure out your vertex and your two zeros, you've solved all of the problems they're ever going to give you about parabolas. Understand? Those 3 points are the most important points. Vertex and your two zeros. What else you got?
Well, so he posts the answer key to our reviews. And the solutions are different. For the one we did, the 2x squared minus 12x equals, equals negative 17.
Uh-huh.
They said the solution is like 2.29.
Well, what did I come up with? I came up with 2 plus and 3 plus, right? 2.9 is 2 plus. I hate the fact that they're giving you that solution because that's not the way it's done in math. You keep it exact. The solution was a radical answer. In other words, an answer that involved radical numbers. You know what I mean by that?
Yeah.
It was the square root of something. It's not a decimal number. You do not take radical numbers and approximate them to decimal numbers. You do that in 8th grade algebra. You don't do it in 10th grade algebra. In 10th grade algebra, you give your answers in radical form. I don't know what your teacher is requesting, but that's the way it's done in math. If your teacher is requesting a decimal answer, then you got to put it into your calculator and come up with a decimal approximation, which you should know means rounding it off. It's not an exact answer. 2.9 is not the correct answer. Give me another one. Let's start again. We'll talk about it.
Okay, so
got time for about one more. You might want to pick one of your, assume we only have time for one more. Pick the toughest one you want. Well, that might not even be the best way to go. Pick one you don't know how to go. Pick the easiest one that you don't know how to do. That's the way to go.
So it says to write each equation in vertex form, then name the vertex, line of symmetry, and the direction of the opening.
Got it. What's the function?
Y equals 2x plus 6x
squared. Right?
No, just
2x?
No, just x squared.
Oh, just x squared. Okay, hold on. Go on.
Plus 6x plus 2.
Okay. This is not a quadratic you can factor. There's no way I can set up 2 parentheses and come up with an answer. Which means if I want to know my zeros, I got to use the quadratic formula. However, let's go back and read the instructions. What do they want to know? They want to know the vertex, correct?
Yes.
Okay. So, there are, they wanted to know it by putting it in vertex format. There's a lot of subtleties in algebra. There's multiple ways of doing stuff. Okay? Let me put the general equation of vertex format. Here it is. Got to memorize that. There's just no other way to do math other than memorize it. Okay? You with me?
Yeah.
The only way to take that function that you're looking at, x squared plus 6x plus 2, and put it into vertex format is by completing the square. Another process that you have to learn in order to get through Algebra 2. Well, if I want to complete the square on this, I can show you the technique. Again, you have to memorize it. Have I changed anything from the original function? Is my bottom line the same as my top line?
Yes.
Absolutely. And that's key. We don't want to change anything. As I go from line to line, I got to make sure I do not change anything. Okay? Now, the process of completing the square. It's not a complicated one. I'm going to complete the square inside the parentheses. And the way you complete the square is you take half of the coefficient of the x term. What's the coefficient of the x term?
Just x.
What's the coefficient of the x term?
The 2 squared.
It's the number in front of the x.
Is it just 1 then?
6. Plus 6. In other words, you have to know what coefficient means. Coefficient is the number in front of the variable. Always. That's what coefficient means. So if I ask you, what's the coefficient of the x squared term? What is the coefficient of the x squared term?
1.
Correct. What's the coefficient of the x term?
6.
We're going to take half of that coefficient. We're going to square it. What is that?
So 3 squared.
Which is?
9.
Okay. So I'm going to put a plus 9 right there. Now I just changed things. I just added 9 to the right side of the equation. Well, I can't do that. I got to keep the equation the same. So what do I have to do to balance it?
Put it on both sides.
No? Put it all on the same side. What do I got to do to balance out adding 9 to the right side of the equation?
Add 9 to the other.
Nope. Do it all on one side. It's the only way it works when you're trying to take a quadratic and put it into vertex format. You have to do everything on one side of the equation. So I just added 9. How can I balance this out so that I haven't changed things? Well, we subtract 9. Now, do I still have the same thing I started with?
Yeah.
Yeah, I didn't do anything. The only thing I did was add 9 and subtract 9 to the same side of the equation. So I still got the same thing I started with. The advantage is that because I completed the square with that, I can now write that as x plus 3, whatever you got when you took half of 6, squared. X plus 3 squared is x squared plus 6x plus 9. Combine these two numbers and I get minus 7. So, is the bottom line the same as the top line?
Yes.
Yeah, absolutely. I was very, very focused on not changing it when I go from line to line. And notice that the bottom line is in that format. It's exactly that format. What is H? Well, let's start. What is A?
Is it x squared?
It's 1. Coefficient in front of that term is 1. So A equals 1. What does H equal?
6.
If x minus h equals x plus 3, what is h?
2.
It's minus 3. Now, do you see where x minus a minus 3 comes out to be x plus 3?
Yeah.
That's why h is minus 3. In other words, you have to let h be whatever it has to be so that x minus h equals x plus 3. The only way that can happen is if h is minus 3. How about k?
Nine.
There's k right there. What are we looking at? Minus 7. What's k?
-7.
Got it. Now, what are h and k? That's the coordinates of the vertex. That's the beauty of the vertex format, is that when you put it in vertex format, you are staring at the x and y coordinates of the vertex. And that's actually the most important point that you can start out finding. Not the zeros so much as it is the vertex. If you look at any parabola, you can tell that the vertex is the most important point of that parabola. Okay? So, I got the beginnings of how to graph this. I start with the vertex. Does it open up or down?
Up.
Correct, because the coefficient in front of the x squared is positive. Where's my vertex?
0.
H and k are your x and y coordinates of the vertex. That's the whole point of putting it into vertex format. It tells you where the vertex is. Where is the vertex? It's not the A, it's the H and K. Where's my vertex?
-3.
And it's a point. What's the point? I need an x coordinate and a y coordinate.
-3 and -7.
Perfect. -3 is right there. -7 is right there. So that's my vertex right there. Okay? I know it points up, right?
Yeah.
So it does something like that. Now, they asked you where the vertex is, right? There's the vertex, -3, -7. The next thing they asked you was the axis of symmetry. That's this dotted line that runs through the vertex. Always a vertical line. What is it? It's x equal -3. In other words, whatever the coordinate, the x coordinate of the vertex, that's the axis of symmetry. Can you see that? That dotted line goes through x equal -3. What's the next thing they ask you for?
Just the direction of opening.
Opens up. There is one additional thing they might ask you. What are the zeros? Remember that all parabolas, any 3 points define a parabola. So the vertex is the most important point, but you still need 2 more points. Usually those 2 points come from the zero. Well, if I want to find the zeros, I'll let y equal 0. Because when I cross the x-axis, what is y equal to? What's y equal to at the 2 points that I've circled?
-3.
No. Y is 0 at both of those points. You see why? Can you look at my graph and see why y is 0? Whenever I'm on the x-axis, y is 0.
Yeah.
Whenever I'm on the y-axis, x is 0. Very important point to remember. So if I want to figure out where these 2 points are that I've circled, I let y equal 0. Not y, but 0. And then I solve that equation. And I have to use the quadratic formula again to find it. But we're out of time, and they didn't ask for it anyway with this problem. But I guarantee you they expect you to know it. In other words, when they are giving you quadratics, and they want to know the vertex and the zeros, this is the process you have to go through. You put it in vertex format using completing the square. There's a lot of math involved in this problem. And it's enough math that you and I would have to spend an hour to go over it. So it's not something that you can learn in 3 minutes or 5 minutes, whatever time we had here. So let's end it there. But this is good. This is the kind of stuff you're going to be tested on. You just need to do more of it. Here's what's going on, Maddie. If you're giving me a semester's worth of Algebra 2 and you want to learn it in a half an hour, that's impossible.
Yeah.
You need to give me more time to teach you these things. But there are lots of things involved here. There's completing the square in order to put it into vertex format. There's the quadratic formula to solve for the zeros. There's just so much stuff you can't go over it, all of it in an hour. You just can't do it.
Yeah. And the hard part is like a lot of these things, it's the first time I've ever seen it.
Well, I understand that. I do. I just don't know what to do about it. In other words, there's a certain amount of memorization that you have to do. And if you don't memorize these, there's no way to be able to answer the questions.
Yeah.
You have to memorize the stuff that you have to memorize. That's basically it with all of math. Math involves a lot of memorization. And if you can't memorize it, you got no chance. So the first thing you have to be able to do is memorize something.
Yeah, it's just like I don't even know, because like this vertex form thing, like he's never mentioned that ever.
Well, let's talk about it again. What you want to memorize is this. That is a critical part of algebra, knowing that.
He's never mentioned it once.
Well, I don't know what to tell you. I know you missed a lot of school and maybe you just didn't pick it up when he was talking about it. But if we're trying to cover it and I'm trying to teach it to you, you got to memorize that. That's something you have to know, is the vertex format. There are actually 3 formats for a quadratic. Vertex is just one of them.
Yeah.
And you have to know them all. There's the vertex format, there's the x-intercept format, and there's standard format. They're all different, and they all kind of teach you different things. If the question is how do you find the vertex, the easiest thing to do is to put it in vertex format, because H and K are the vertex. In other words, if you can get a quadratic into vertex format, you know where the vertex is. Just read it off your final answer once you get it into vertex format. It's whatever H and K are. But to put a quadratic, in other words, up here, that's standard format. X squared plus 6x plus 2, that is standard format. To put it into vertex format requires you to know how to complete the square. Another Algebra 2 process that you cannot get through Algebra 2 without learning how to complete the square. So we covered that. Once you know how to complete the square, you can put this thing into vertex format, and then you know where the vertex is. Just read it from whatever you get. That's H and K. So, I don't know, eventually we'll have enough, with the next couple sessions that you've scheduled, we have enough time to cover some of these things. But you're asking a lot. You're asking me to teach you a semester's worth of Algebra 2 in 2 hours or 3 hours or whatever you have scheduled.
Yeah, I understand.
A semester worth of Algebra 2 is like 15 or 20 hours.
Yeah.
There's no way to shorten it. And it definitely requires you to memorize stuff.
Yeah.
So let's go ahead and stop there. And at your next session, we'll just keep going with the problems you have. And I'll just keep going through it. But one thing that you could probably do to help yourself is to look at the recording of this tutoring session, and that will show you the things. In other words, when you don't know what vertex format is, you'll find it in the recording. If you don't know how to complete the square, you will find it in the recording. If you don't know how to find the axis of symmetry, you will find it in the recording. And the beauty of that is you don't have to pay me anything extra for that. You get a copy of this tutoring session for free.
Yeah.
But what you have to do is review it and memorize the stuff. Math isn't so much about memorizing formulas as it is about memorizing methods. You need to know what method you use to put it into vertex format. That's really what you need to memorize. And that method is completing the square. So you have to memorize both the vertex format and how do you complete the square. Things like that. Okay?
Yeah.
Okay. I'm going to let you go for tonight. Hold on, let me just verify that I have our next session down properly. Let's see, I got nothing else this week. You got the next session next Tuesday at 5:30, is that right?
I think so.
All right. Until then, if you want to work on this, I would suggest you look at the recording. I sent you an email that told you how to find these recordings.
Yeah.
What you're going to be looking for is a file that's got your initials, MM, and the date. So this file would be MM120519. Excuse me. No, that's correct. Yeah. So if you go to my YouTube channel and look at the files that are available for you to view, find the ones that start with MM. And that'll be the recording of your session. And then you can go through it on your own at your own leisure and figure out the stuff you need to memorize. You need to memorize vertex format. You need to memorize the quadratic formula. And you need to memorize the method that we used to put it into vertex format. All of those. can't go further without doing that. Really can't. There's no way to learn math without memorizing it. It just isn't. Maddie, I will talk to you next week.
Okay.
Good night. Have a good week.
Good night.
Bye-bye.
Thank you.